Hello, everyone. Welcome to Microservices with JHipster. I'm Dennis Sharp. I work for EPON as a software architect. This is my first webinar, so please cut me some slack. Just a little bit about EPON to start. We have expertise in digital, big data, and DevOps. You can see some of the products that we work with and have experience with. It's not an exhaustive list, but these are the types of things that we do, consulting. If you want to know more, you can go to our website. In the US, it's eponusa.com. We have an email address here. Also, in Washington, D.C. on July 27th, I'm going to be giving a full day training class on all of JHipster, not just microservices. So with that, I'm going to get right to it. First thing I'm going to do is create a new directory for my microservices. Actually, before that, I'm going to create a directory for my microservices first. Now, under this, what I'm going to do is create a actual microservice project, and I'm also going to create what's called a gateway project. And I have a diagram that's on the JHipster website that I will show in a few minutes while we're waiting for some downloads. So what I'm going to use is Docker, just to make it easier. This can all be done locally on your laptop, but Docker just makes it a little more convenient for demo purposes, and it has some cool features to it. So I'm going to create a subdirectory under my microservices called catalog. I'm going to change to that directory. So under here, I'm just going to run JHipster, and I'm going to create a microservice application. I'm going to take all the defaults. The default port for a microservice, if you're running it locally, is going to be on 8081. Of course, in Docker, that's going to change. But there's some questions here, like what kind of authentication you want to use. I'm going to use JWT, is basically token-based. For a database, I'm just going to use a MySQL database. In this case, we'll call it production. And for development, I'm just going to pick H2. We're going to not actually do any work in development. We'll use Hazelcast for cache. And I am going to turn on Elasticsearch for searching. Use Maven. We'll say yes to internationalization, but I'm just going to pick English for now. And we'll use Gatling for test framework. So that's just created a catalog microservice. Now I'm going to create an entity that exists in that microservice to talk to the database. We'll call it product. I'm just going to add a couple fields to this. This is just a demo, so it's just going to be a couple of made-up things. We're going to have a name with no validation. We'll add a description, also a string. And the last thing we'll add is a price. And we will use a big decimal to hold that. No validation, no more fields, and no relationships for this demo. All of that works just like core JHipster, so it's not really relevant to microservices specifically. There's a couple layers you can have added in to the architecture. between the REST endpoint and the database if you like. I'm saying no to those. Also, you can do pagination using a couple different techniques. I'm going to say no for now to those. JHipster is going to create my entity classes, and then also it wants to update the Liquibase master file. Of course, I wanted to do that because it's going to automatically create my product table for me. So the next step, just to make sure everything is working, is to run Maven test. And this is going to run unit tests that come with the JHipster core, and then a few unit tests that were generated automatically when I created the product entity. Assuming all these tests run correctly, which they did, the next step for this Docker example is we're going to actually use the prod Spring profile, and we're going to create a Docker image. And before that, I have some cleanup to do here. I'm going to get Docker completely clean so we can test this starting from scratch. And I'm going to remove all my Docker images. So I just have Docker for Mac, and so I believe it's still in beta. Seems to be working fine for demo purposes. And you will see that I currently don't have any Docker images loaded. So I'm going to go over here, and I'm going to run my Maven package command and Docker build command. And Docker build will create the Docker image. It's actually going to create two images. It's going to create a Java 8 image, and it's also going to create a image for the catalog microservice. So you will see those. And then this tool that I'm using here behind the command window is actually Kitomatic, I think is how you say it, but it comes with Docker for Mac, or is an add-on to Docker for Mac. And basically, it's just a handy tool to show Docker containers. And it also, you can easily look at the console log for each container you have running, all in the graphical user interface instead of using the command line. So of course, this Maven command also runs all the unit tests over again before generating the Docker images. So this is downloading the Java 8 image, and this is going to vary, of course, based on your network speed. And hopefully, if we get everything downloaded quickly on some of these steps, there'll be a little more time at the end for questions. So that was the Java 8 image that's been downloaded, and now the smaller image that's just for the catalog microservice has been created. So if we flip back over to Kitomatic, we can now see there are two Docker images, one called catalog and one called Java. So our next step is we're going to create a gateway, and I'm just going to call it gateway. And again, I'll show the diagram in a few moments if you're not familiar with the architecture here. So the gateway, we're going to run YoJHipster again, but this time instead of picking microservice application, we're going to pick microservice gateway. So we'll just call it gateway. The default port is 8080, and we'll just pick some defaults: JWT, SQL, MySQL, H2 for dev, Hazelcast. Yes, we want Elasticsearch. And we'll do English and go. Now this one takes a little bit longer to run. It's more like the monolithic JHipster application because the npm and Bower installs run after you generate you run YoJHipster. So this has got the whole front end piece that's going to talk to your microservice, and it also has all the security and other services like that built in. So the gateway has its own database that's separate from your microservice database. You could combine them in the same database with different tables. That's fine, but by default, basically, you're going to have a database for the gateway that's going to have things like your security information, accounts, things like that. You can actually add Cassandra database, I believe, and do more advanced API features like throttling API calls by user and things like that. But basically, the gateway is just that. It's your entryway into all the microservices. It's got your proxy. It's doing load balancing, and all that configuration is in there. There is also a separate server, which we have not created yet, that is the registry. That is something that you can get separately from GitHub and download and run, or we're going to do it with Docker for this webinar, and Docker will automatically pull down the registry and have that as another image that needs to run. So basically, when the gateway and the catalog or the microservice start, they will register with the registry, and the registry will know all the services and all the gateways and their status. So when this finishes, we're going to run the entity generation again for product, just like we did inside the catalog microservice. But the difference is now that we have a gateway, we're going to be asked if we want to use the microservice instead of creating our own entity that's local, like in a monolithic application. Of course, we will say, yes, we want to use the existing microservice. It will ask us where that lives, and we will get the entity regenerated. Basically, all the front-end pieces will be still generated here in the gateway. So the Angular code that's normally generated for doing create, read, update, and delete operations on entities will be here in the gateway. But all the code that actually does the REST endpoint and all the database code will be in the microservice. All right, so now we can go ahead and generate the entity again. And this is where it will ask if we want to generate this entity from an existing microservice, to which we say yes, and we give it the path. And we will regenerate the entity. It'll ask us if we want to overwrite a few of the front-end files that are menus and the like. Of course, we say yes, and there you have it. So now that entity is kind of connected from the gateway through to the actual microservice. So we could run our Maven test, and actually you can run gulp test as well to run the unit tests on the JavaScript files. Or we can just go ahead and do our prod build our Docker container. When we run this build, it will run the Maven test, and it will for the Java unit tests, and it will also run all the unit tests on the JavaScript. After it runs all those tests and everything, of course, compiles successfully, it will generate a Docker image for the gateway, similar to how there's a catalog Docker image. There is one little trick that you have to know about when you're doing microservices with JWT, and that is the token is generated with a secret, a shared secret. That secret is located in the configuration file. In this case, it would be the application-prod.yaml file. So what happens when you create a JWT application with JHipster, that secret is auto-generated for you. So when we ran the catalog, when we created the catalog, a secret was generated. Then we created the gateway, a different secret was generated for that application. So what we need to do is we need to copy the secret from the gateway and put that into the configuration for the catalog, the microservice. You don't have to do this if you use the config server, but I'm just not currently using the config server. So I'll talk about the config server in a few moments when we're waiting for Docker Compose to run. But since we're not using that, you basically copy. So first, we'll see that this test is working and the Docker image is created. Okay, so we refresh over here, and you will see now we have a gateway Docker image along with our catalog Java. So we need to go into the gateway. There's a source resources in the normal Maven pattern. Inside there is a config directory, and there are several config files. The one we care about is application.prod.yaml. Now, if we just do a search for JWT, you'll see here there is a secret in this file. So we need to copy that secret. And we basically need to go to the catalog microservice in the same directory Find the same place and take this secret out. And paste the one from Gateway. We are going to have to run our Maven command again to regenerate the Docker image. Now, if you do not do this step, when you try to communicate from the gateway to the microservice, you will get an error in your console that says the JWT, the token, is not valid. So that's your clue when you get that token is not valid. Okay, there's a mismatch between the secret that's used to generate that token. Sometimes, just another thing, there is an error that will come up when you run the Docker build, and it relates to some sort of connection refused error, and we are adding that to the JHipster documentation on the website, as just to let you know that there's just an export command on the Mac you have to run to fix that. Here we are. This is the exact error I'm talking about. So it looks like some kind of weird, okay, connect to localhost, connection refused. Is this some sort of security problem, or what is this? And basically, the command you need to run, again, this would be on the website, is this. So that export makes it so when you run the command again, it should succeed. Once this is run, the next step is to actually create a Docker Compose subdirectory. And Docker Compose, there's a JHipster Docker Compose command, and that's going to actually create all the other images that we need. We'll make a Docker Compose directory. We'll go into that directory. We will run the JHipster Docker Compose command. That's going to ask what the root directory of your microservices is, and it's relative to this, it's ... so that's correct. And then what applications that we've generated do we want to actually make part of this Docker configuration? And we want both of them, catalog and our gateway, the microservice and the gateway. And then it also asks if you want to use Elk stack. So if you're familiar with that, it's Elasticsearch, Logstash, and Kibana. That comes with, and then it asks you for an admin password for the registry. I'm just going to take the default. So it's just generating some config files, basically. The real work happens when you actually run the Docker Compose up command. So once you run that command, there's a lot of downloading that's going to take place because we need to get Elasticsearch. So if you're running this all locally and you weren't using Docker, then you can go with a couple of different approaches. If you're doing it more in dev mode, you can use Elasticsearch kind of embedded, not the real deal. But if you want to do a more prod-like scenario, you would need to install Elasticsearch yourself. Also, MySQL, for instance, is the database we picked. Now, if you're doing local, you could be using H2 with file-based caching. But if you want to do a more like production-like configuration, then you would need to install MySQL yourself and set that up to have the database for both the gateway and the microservice. Then also you would have to go to GitHub and get the JHipster registry, which is easy enough to do. You can clone that and then you just run Maven and it will kick it off. Or in this case, that will be another one of the images that's downloaded automatically and run inside Docker. So I promised that while this was running, I would show the diagram, the architectural diagram of the microservices. So this is exactly copied from the JHipster website if you want to look at it later. So the gateway that we generated has our Angular code, and it has the Zuul proxy, and then this is using the Netflix Spring Cloud architecture. So if you're not familiar with that, maybe this will be a little confusing, but basically Netflix provides some tools that are open source that are being used here by JHipster and Spring Cloud also. So it uses this Zuul proxy, that's your proxy server. So you can give it different types of configuration and paths and tell it based on this path, go to this service. And then Ribbon is the load balancer that sits with that. And like I mentioned before, there's access control that's being done by the gateway. So users and roles and all that, that is still being controlled at the gateway level in JHipster. The microservices are separate, and of course you can have as many different microservices as you want running. When microservices or the gateway start, they will register with the JHipster registry. That is basically a Eureka server, which is more net, and a server, which we don't at the moment, but config, you can put your configuration in a Git repo and have that be the source of config for all your applications. So Spring Cloud config is used to retrieve that. All of these servers talk to the JHipster console, which is your Elk stack, Elasticsearch, Logstash, and Kibana. And then your browser can hit Kibana on port 5601 by default and see the normal, and I'll show you that once we have everything up and running. But that's the basic architecture that's being generated for you. And you'll see I'm doing it here. It's basically a half-hour task to set up a microservice and a gateway and have it all talking together. Let's see how that is going. Looks like we're downloading the registry currently. So I thought if there's a few more minutes before the download's complete, I could show you just a little bit of the code. It's a much longer task to go through all the code in detail and how it's structured and where everything is. So I'll leave that as an exercise for you guys. But the main thing here is we have our catalog. We basically have two projects that were generated. I have them loaded up here in STS. The catalog is the microservice. There is a product resource, which is the REST endpoint that's generated when we created that product entity. So that's going to have your normal create, read, update, and delete operations. And I think I'm going to pause here to maybe answer a few questions while we're waiting on the Docker image download. So one of the questions is about load balancing needing several gateways from Julian. And no, the gateway is load balancing between several microservices. So we're looking at load balancing more from on the microservice side, not talking about load balancing the gateway itself.
Sub question.
Oh, and then I see for the front end part. Okay. That's actually a good question. I don't know that we're load balancing on the front end. That might be one I have to take back. See other questions. You say Docker Compose does not work here. I'm not sure. Can you be a little more specific, Julian? The Docker Compose file is in version 2. I'm still, are you? Okay, I got you, yeah. Well, everything, as far as JHipster goes, this is version 3 of JHipster. So you need that to do microservices. But as far as Docker goes, honestly, I just installed Docker for the first time 2 weeks ago. So I'm very new to Docker, but I was actually very impressed with how easy it was to get up and running on my Mac and then get the microservices up and running using Docker. We have some other people we have a Docker captain on staff who I go to for any tricky Docker questions. So this is still running. I'll flip back to the code. So basically you have your REST endpoint that's generated, and then inside the gateway application, there's some configuration that you can do with the gateway. I was talking about this before. There's a rate limiter and there's all kinds of configuration you can do with the Zuul gateway. And then also on the front end, the Angular code that's generated that talks to the REST endpoint on the microservice, it looks kind of like this here. So you'll see that the name of the microservice is at the beginning of the URL, and then the rest is kind of the normal API pattern followed by JHipster and most people with REST APIs. There's a whole bunch of code here. Obviously, you can see that you could go to my all-day class to learn more about that. We're still waiting on the last bit of download. So this is Logstash. So the whole Elk stack is being downloaded into Docker containers. If you didn't do that and you wanted to use Elk, obviously you have to install Elk yourself. Or of course, you could if you have Elk stack running on a server somewhere, you could connect to that instead. Once all these images are downloaded, all the containers will be started automatically. There's a little bit of a pause built into the gateway and the microservice apps to allow for, basically, if you've ever done this locally, you would see very quickly, if you don't have the registry up, then you can't bring up the gateway and you can't bring up the microservices, because the first thing they were going to do is try to register with the registry. So of course you can turn that off, but that's the default. The default is they're going to, everything that you build with the JHipster 3 and the microservices is going to be set up to talk to the registry. While we're waiting, we can look at a few more things. Everything in JHipster monolith or microservice is using the Java configuration. So I see we have another question here. Is it possible to create Angular factories in your microservice and share it in the gateway? That is a little bit confusing to me, because the microservices are purely, REST endpoints. So they don't generate Angular code. When you go to your gateway and you hook to that microservice, that's when you get your Angular code. And that just uses whatever the default, it's like the John Papa's style guide that's being followed for the architecture behind the Angular that's set up to call these REST endpoints. If you wanted to change how that was done, then you can either, this is open source, you can then tweak the generator itself to do something custom if you like. But there's no option to generate the Angular in any way different from the way it's done right now. You notice there are no questions about how do you want to structure your Angular code or any questions about that. It just kind of chooses what's kind of considered a pretty standard setup to talk to your REST endpoints. So you can always change it. I've customized JHipster, not the microservices, but the monolith. And it's not it's all generated using Yeoman, and it's all JavaScript. So you can make changes. The network is slow for me right now. Here we go. All right, all the images have been created. If I go back over here to my Docker console, you can see lots more images now that are all running or starting right now. You can see all the images over here on the right-hand side. So what you can do is you can actually click on one of these, and you can see the, excuse the train. You can see the registry, for instance, is going to start up the fastest. And you can watch the console here and until it gets running. But you can see there's a two different Elasticsearches started here. There's one for the catalog and one for the gateway. There's two different MySQLs. The gateway has a MySQL. The catalog has a MySQL. The Elk Stack, Elasticsearch, Logstash. All right, now the registry is up. The default port for that, 8761. If it looks familiar, it's generated with JHipster. So this is a dashboard that comes up when the instances of our gateway or the microservices come up. They will show up in the instances registered here. Then we have some other kind of system dashboard stats type things about the system and what other services are up and things like that. You can go look at the applications, which of course there are none at this second. The instances there. Varied other functions. So we'll go back over here and look. Okay, the registry's up. What about catalog? And I mentioned earlier there's a delay. That's baked in, so this will not try to start before the registry is finished. Also, because of Hazelcast, I chose to use Hazelcast Cache. If more instances are spun up, they will automatically join the cache. They will be auto-discovered. It will work in a clustered fashion. This is almost started. You can see here in the log it's registering with our registry. There we go. So if we refresh this, now you see we have our catalog web service and our gateway both up and running. You can also go to the application tab and see there's one instance of each. Normally, I could show you adding an entity, and that would add it in the catalog database. I'm going to skip that part because there's one last thing I'd like to show before we run out of time, and that is how easy it is to scale up, especially with Docker. So we're running this application, we're running our gateway, the catalog service is getting pounded, it's just not able to keep up. We need another catalog service. How do we make that happen? Well, go to Docker Compose, scale, catalog app equals 2. Okay, go back over here to the console, refresh. Oh, we have another catalog. So the new catalogs service is starting up right now. It's a new microservice. If we go to the console and refresh, too fast. There you can see our new catalog web service is in the middle of starting up. When it's done, it'll be automatically load balanced and available to take some of the load off the original service. There you do. There you go. If you go to this view, you can see now there's 2 instances of the catalog microservice running. And of course, you can do that. To some theoretical limit, I suppose. But so that was basically what I wanted to show with the microservices, is how I started basically from total scratch, nothing, completely started with a new directory. And in 45 minutes, we had a granted simple microservice running, a gateway running. We actually had 2 instances of a microservice running, and everything is set up in a production-like configuration with load balancing and the ability to do all kinds of other things with the Netflix libraries, like rate limiting and things like that. But a fully production-ready style application with the dashboard and the Elk Stack. And I did not show the Elk Stack. I'll show that real quick. If you're familiar, Elk. But this is pretty much just the Kibana interface with a little JHipster header at the top there. And this has got all the logs from everything that we've done so far. And you can search the logs and everything, do your graphing and highlight parts and all the things that you can normally do with Kibana to narrow down what you're looking for debugging purposes or troubleshooting. So all of that just came with using the commands. So that's about all I have to show you. I don't know if there are any questions, if we have time for any questions to answer, but. You can also email us if you have questions. And I have the slide up here for training as well to remind you that if you want to do the full JHipster and not just microservices, we're doing that in Washington, D.C. on July 27th. Looks like we have a question coming in. So the microservice architecture, there's two pieces that you can use, or you can use only the microservice section if you want. If you only use the microservice generator, then that will generate REST endpoints, and you are free to use any front end that you like, completely outside of the scope of JHipster. However, if you want a front end that is in the style of what JHipster gives you with Angular and get the create, read, only, create, read, update, delete type functions in Angular built for you and generated for you, you can then run the front end piece to do that. Or if you're looking to just have your gateway, a separate gateway server that is more like your proxy and does your load balancing, you can generate it just for that as well. But you don't have to use the JHipster front end if that's what the question is. But you do get a front end if you want it. Did that answer your question, Julian? Now, the generated code in the gateway is not just for administration. Oh, okay. So I didn't show you the actual application is why there's some confusion.
Julien's good. Julien's good. There was another question.
Yeah, I'm not a Docker expert to answer the Docker question, but the registry created by Docker, I'm pretty sure you just have to open ports in the Docker container to allow anybody to contact that registry. So it's just a Docker config issue. And this here I'm showing you is the actual front end that's generated. So I sort of skipped this part in the interest of time, but basically when you create an entity in the gateway, you will get this whole Java JHipster front end, and one of the things you get is this product screen, and it's got basic your basic functions. It's not something you would probably end up using directly as is in a production application, but it gives you kind of the setup so it's easy for you to say, okay, well, I want to be able to create a new product and I'm going to build my own screen, but the functionality behind it is going to be basically, already here. Sometimes the first time I do this, it times out on Docker. But got some network issues here. Okay. So this works just like the core JHipster, not the microservice edition. I mean, it also works the monolith as well. Of course, I'm having difficulties with the network right now with Docker, but basically what happens is the product gets created here in this list, and then you can edit the product or delete it. So it's a pretty simple front end, but it is a front end that's generated with Angular that you can then modify and make work however you like. So it's a good starting point. I could probably troubleshoot this, but I think we're running over time, so.
Question. Maybe the last question.
Have I tried deploying this on a cloud infrastructure? Not microservices. I have deployed the monolith on, we've done it for Heroku. I believe it was just Heroku that we've tried it in the office, but I believe that I did try AWS actually. I was able to get AWS to work. That's kind of, I think that's a beta task right now in JHipster, but you can run a JHipster AWS command and it will deploy to AWS for you. And that did work for me. But I haven't tried it with the microservices. Right, yeah, I think that for the Docker questions, again, I'm not an expert, but I think you have to open ports in the Docker container themselves to allow outside processes to talk to them. Yeah, the question is if you have your own or a separate interface, you would need to provide a web token. That's correct. You need to, basically, you want to use the JWT standard, and you're going to need to share a secret with the microservices. The reason we took it from the gateway and copied it from there is that actually that piece, that secret is in two places. It's on the server side code, and it's also out in the Angular code as well. So I think that answers that question. Okay. Yeah, I think.
We can do a Docker webinar.
Okay, I think we're good on questions. Thank you, guys. I appreciate it. And you can follow us on Twitter and our website. And if you need more information or if you want to contact us to get more information about microservices and JHipster. Thank you.